In question 2 of our gases and chemical reaction series, we're asked, in the following reaction, 4.58 liters of oxygen gas is formed at a pressure of 745 millimeters of mercury and a temperature of 308 Kelvin. How many grams of silver 1 oxide decomposed? We've been given the chemical reaction formula for what's going on, and we've also been provided the molar mass of Ag2O. The first thing that I want to do is write down everything that's been provided. We've been told the volume of oxygen, it's 4.58 liters. Been told the pressure is 745 mmHg. And the temperature is equal to 308 Kelvin. To answer this successfully, we have to use the ideal gas law along with some stoichiometry. From the information that's been provided, we can actually find the number of moles of oxygen. Using the number of moles of oxygen, I can then set up a mole ratio to find the number of moles of silver oxide. From there, and using this molar mass, I can find out its mass. Writing out the ideal gas law, we have PV is equal to nRT. I'm looking for the number of moles. So I have PV over RT is equal to N. Pretend we divide both sides by RT, cancels out on the right side, and then remains on the left side. So I'll substitute the values that I have. I know the pressure, but it's in millimeters of mercury. I need to change that into atmosphere. The conversion ratio is 1 atmosphere for every 760 millimeters of mercury. By multiplying this number by that, this unit cancels out with the units of 745, and we end up with atmosphere. 745 divided by 760. This gives us 0.9802. 0.9802 atmosphere. I'll substitute that into P. Multiplied by the volume of 4.58 divided by the constant R, which is 0.082057, and that's being multiplied to the temperature of 308. Multiplying and dividing all of these will give us the number of moles. Let's use our calculator. The number on our screen times 4.58 divided by 0.082057 times 308. That gives us 0.1776. 0.1776. And remember, we should have 3 significant figures here. So to remind me of the amount of significant figures, I'll put a dot underneath the 7. I'll keep the 6 just to prevent any rounding errors moving forward. I'll write my findings here, and I'll set up a mole ratio with silver oxide. I have a 2:1 ratio. So if I place this number right here and multiply it by 2, and n is my unknown, multiplying that by 1 gives me n is equal to 2 times this number, 0.3552. 0.3552 is the amount of moles of Ag2O. They're looking for the grams. So what I'll do is take this number and multiply it by the molar mass. Because by multiplying it by the molar mass, this mole unit and this mole unit will go away, giving you the grams. So taking this number, multiplying it by 231.74, and I end up with 82.3. So the mass is 82.3 grams. That is the amount of grams of silver oxide required to form this much volume of oxygen. In question 3, they ask, in the above reaction, what mass of silver oxide in grams is required to form 388 milliliters of oxygen gas at the pressure of 734 millimeters of mercury and at a temperature of 25 degrees Celsius. We did a very similar problem to this in question number 1, so I'm going to leave this one to you. If you have any questions about it, feel free to use our website for more assistance. And that is how to calculate volume and mass of gases in chemical reactions.